In this last bond screencast, I'm going to work through some of the problems on the problem set with you and illustrate a couple of important concepts with bonds. The important thing, I don't know that I've mentioned it thus far in this course, but the important thing with problems that we do in Finance 355 is that the problems always illustrate the concepts we're looking at. So it's useful sometimes to just look at concepts via the problems. So let's look at the problem set. So I hope you have it handy. Here are the solutions posted just as they are on D2L. So let's start with problem number 1, and we're going to completely shift gears from what I showed you in the second screencast, and now we're going to just jump to the assumption of semi-annual coupon payments, because that's how coupon payments are typically made for bonds. So problem number 1, the first part there, is pretty much the same question that you had in the second screencast where we found the different values of a bond, but here we're going to find them with semi-annual coupon payments. So the first part of problem 1 says, what is the value of a bond that has a semi-annual coupon payment at a rate of 10%, a yield to maturity of 10%, and has 10 years to maturity? We use the exact same time value of money variables that we did in the screencast, and even if coupon payments are made semi-annually, you see in the solutions there, and I'm not even going to plug this into the calculator because it's going to be the same, but you see here that it's still going to equal par, even if the coupon payments are made semi-annually. If the coupon rate is the same as the yield to maturity, the bond's going to sell at par. So let's look at the second part of this problem, and let's walk through this whole thing together. So suppose the company has these 10-year bonds with the same required rate of return, 10%. That's just another way to refer to yield to maturity, and an annual coupon rate of 13%. What is the bond currently selling for? So now we've shifted gears to these semi-annual coupon payments. What do you do? Our future value is still 1,000. We have to make adjustments though to 3 things. We have to adjust our N for total periods. That should make sense. So it's compounded semi-annually, so it's 10 times 2, our N becomes 20. We have to make a periodic rate adjustment to our I. So as we did with time value of money problems, we often changed, or I often changed the P/Y, or your other option was to make a periodic rate adjustment. That's what we're doing here when we plug in yield to maturity. We're dividing the yield to maturity annual rate of 10% by the compounding periods per year. In this case, it's 2, and we're going to plug in 5. And then the payment we find like this. We take the market rate, or not the market rate, it's the coupon rate. We take that coupon rate of 13%, 0.13, times 1,000, just as we did before, but now we're going to divide that by 2 because the investor, would be getting payments of $65 instead of $130. And then we solve for the present value. So let's give it a shot. Clear out our time value of money. Enter $1,000 as a future value. Enter our 20 for our N. Enter 5 for our I/Y. Our payment of $65, and compute our present value. And bingo. We find that the bond is selling for $1,186.93. It's a premium bond. The present value is greater than the future value, and the coupon rate is greater than the yield to maturity. The last part of problem 1 says, what would the bond currently be selling for if the coupon rate was 7%? So only the payment changes, just as it did in the last segment that we solved. So now your payment is computed by taking 0.07 times 1,000 divided by 2 for a $35 coupon payment. That's all that changes. So you can just plug in that new payment, compute your present value, and $813.07 is the price of this bond. It's a discount bond, you discover. The present value is less than the future value, and the coupon rate is less than the yield to maturity. Let's scroll down to problem number 2 and look at how this works out with yield to maturity. In problem 2, you're asked for the yield to maturity on a 10-year 9% semi-annual coupon bond selling for $887, future value $1,000, N is going to be 20, 10 times 2. The present value, negative 887. The payment, I illustrate here both ways. Typically, I just take the coupon rate of 9% multiplied by par, 1,000, divided by 2. But sometimes accounting students who are used to looking at yield to maturity on bond problems are used to doing it like this. So I included in my notes just as an illustrative purpose for you. You get the same thing either way. It just is a different way of doing it. So the payment's $45. Plug all these inputs into your calculator and compute for your I, and you should get 5.4409. So let's give it a shot. 1,000, future value, 20 was our N, 887 was our present value, or the selling price, 45 was our payment, and make sure you plug that present value in as negative if you didn't already do so, and compute your I and 5.4409. This is a semi-annual rate though. This is literally a periodic rate, if you will. You need the annualized yield to maturity, so you multiply it by 2, and you can just do that straight from here in your calculator, and you can round to the second decimal place. 10.88% is the yield to maturity. The second part of the question, I ask you, what would the yield to maturity on that same bond be if the current selling price was more? If it was $1134.20, only the price changes. Everything else stays the same. $1,134.20. That's a cash outflow, so that's our negative. For the investor, plug that in as your present value, compute your I, should get 3.55136, etc., or just round to 3.5514. Go ahead, multiply that by 2, and 7.10% is the yield to maturity. Notice that as the present value went up, the yield to maturity went down. There's an inverse relationship I mentioned before between yields on securities and their selling prices, and that's exactly what happened here. Okay, this case we just computed the yield compared to the selling price. But if the price goes up, yield to maturity is going to go down. If the price goes down, yield to maturity is going to go up, and vice versa is the case. Number 3 has us moving on to a different concept, and that is of the zero coupon bond. And you may have read about these in your textbook. They're simply bonds that have no coupon payments. Why would an investor buy a zero coupon bond? Well, you still essentially see a decent return. That's still your yield to maturity, or your total return as the investor, in this case 8%. You pay a much smaller amount to get $1,000 when it matures. It can be an attractive feature for some investors, especially those that maybe don't want to worry about, for tax purposes, reporting those coupon payments every year. So how do you plug this into your calculator? I think it's pretty straightforward. The solutions are all there for you. A couple of things to note. There is no semi-annual rate adjustment with these because there's no coupon payments. You just leave out the payment and make no adjustments because there's nothing to adjust, because nothing's occurring semi-annually. Find the present values based on these changes in yield to maturity, just illustrating the point once again of that inverse relationship. I think you can get that by plugging that into your calculator just fine on your own. Scrolling down to current yield. Current yield is the miscellaneous concept I mentioned, and the first screencast, current yield, can be found by taking the annual coupon payment and dividing that by the current price. Remember, I mentioned to you that current yield is often quoted with bond quotes, It's essentially the return an investor realizes based on the cash income they're going to receive in the coming year. So in this case, the annual coupon payment would be the 0.08 for the 8% coupon rate times 1,000 times par for $80 divided by the price of $1,090, and the current yield is 7.34%. Moving down to problem number 5. Venice Corporation has $1,000 par value bonds outstanding that were issued 5 years ago. So they're 30-year bonds, but they were issued 5 years ago. So essentially they have 25 years remaining to maturity. The coupon rate is 15%, and the yield on similar bonds is now 12%. What is this bond selling for currently? That's the question you're being asked. So the future value, still assume that $1,000. The tricky thing in situations like this or problems like this is the N. It's a 30-year bond, but it was issued 5 years ago. So what do you do there? Take 30 minus 5 times 2. That's our N, 50. Adjust the I just as you would normally. 12 divided by 2 for 6. The payment of 0.15 times 1,000 divided by 2, $75. Compute the present value to find that the bond's current selling price is $1,236.43. It's a premium bond. The coupon rate is greater than the yield to maturity, and the present value is greater than the future value. Question number 6. Venice Corporation has $1,000 par value bonds outstanding issued for 30 years, 5 years ago at a coupon rate of 15%. What is it yielding if it's selling for $938.81? Here you're just solving for the yield to maturity. I think you can handle that one. I'm going to skip past that one. Let's look at number 7. This is a problem in the classroom that I would typically ask some questions before we solve the problem, just to get everyone thinking. Given the information in the problem, J. Peterman has a bond outstanding that has a $1,000 par value, a market price of $1,322, has 25 years remaining to maturity, and assuming an annual market interest rate of 8% and that the bond pays interest semi-annually, calculate the annual coupon rate on the bond. So do you think, before you do anything, that this coupon rate is going to be less than or greater than the yield to maturity? And how would you know? These are the types of questions that I ask on exams related to bond valuation. Lots of hypotheticals without necessarily a problem, just given some information. Based on the bond rules of thumb, you know it's a premium bond. It's selling for more than the investor receives at maturity. Present value is greater than future value. So given that it's a premium bond, the coupon rate is definitely going to be greater than the yield to maturity. And in this case, you're solving for the coupon rate. So how do you go about doing that? Pretty straightforward. It's all right there in front of you. You solve for the payment. Take the payment, multiply it by 2, divide it by 1,000, and you should get 11%. All right. One last concept that I did not go over in the previous screencast or anything so far, and that's this concept of yield to call. Yield to call, if you read about bonds in Chapter 7 in your textbook already before doing the screencast, you learned a little bit about callable bonds, how investors might have an option to call a bond. All these different options and features of bonds are written into the contract when the bonds are issued. Yield to call is the rate of return that would be earned on a bond when it's called before its maturity date. So it's called kind of prematurely. This only applies to callable bonds. It replaces yield to maturity on the callable bonds because the investor does not have that option to hold the bond until it matures. So what you compute is essentially the yield that the investor earns in the time they might hold the bond if it's going to be called in 5 years. So how do you set this up? Well, Kramerica Incorporated has bonds that sell for $1,180. They have a par value of $1,000. They pay a $105 annual coupon payment, and they have a 15-year maturity, but they can be called in 5 years at $1,100. So they're called typically higher than par. We call that a call premium or the call price. The company, the issuer of the bond, is paying a premium for that option to call the bond. So why would an issuer call a bond before it's mature? Well, if interest rates go down would be the perfect answer. If they suspect interest rates are going to go down, they might want that option to call them so they can reissue them at a lower interest rate. There's all kinds of other reasons. That's kind of the most typical one that makes perfect sense. So what do you plug into your calculator? Notice we just keep things here in this class with yield to call simple on an annual basis. So the present value, that's the selling price, $1,180. Make that negative just as you have all along. The future value will be the call price, what it's going to be called for. So that's $1,100. Our N is the periods to call, okay? That becomes the periods to call. It could be called in 5 years, and that's what we're looking at. Payment, that's the coupon amount, and I gave that to you in the problem. The yield to call is a rate, so you compute the I, and in this case you find 7.74% is the yield to call. This is essentially the return the investor would receive. This is their yield, if you will, if they held on to that bond for 5 years and it was called at that point. So that's yield to call. Number 9 is another yield to call type problem. Just having you look at yield to call versus yield to maturity. The solutions are right there in front of you. I think you can get it just by looking at those. I don't think you need me to talk over them. I hope this was helpful for you. If you have any questions, as always, of course, email me. Thank you, and best of luck on bond valuation problems. I know they're tricky. Please do not hesitate to email me or post a question to D2L if you're struggling. All right? Happy studies.